Hello everyone, I welcome you all to today's session which is on numbers again, right. We will be continuing from the previous concept that we have discussed. So, we have the series of videos on YouTube, right, wherein we regularly upload videos, right. So, there are like around 10 to 12, maybe 15 videos that we are uploading in a month, right. Questions based videos and concept based videos, right. There are two categories of videos that we have been uploading on the YouTube channel. Do check them out and do consider subscribing to us, right, so that you can get access and notified whenever we release any new content on our channel. So, by the way, today's video is on the remainder theorem concept, right. So, remainder theorem, last class if you recall, from remainders we have covered pattern method, right. So, pattern method we have covered in detail in the previous, and also we have just touched upon the observation based method. Today's class will be on remainder theorem method. Let us study that. Now, let us start by understanding what do we mean by remainder theorem, and then we shall look at how do we use it in our problems involving remainder calculations in numbers. So, remainder theorem, the statement goes like this: if a polynomial function f of x is divided by x minus a divisor x minus a, then the remainder will be f of a. Then the remainder will be f of a. So, for example, as an example, say f of x is x cube plus 3x square plus 4x plus 5, suppose, and then we have to check what will be remainder when this is divided by x minus 1, suppose. What will be the remainder? So, how do we do it? The regular way is you divide this polynomial. So, how do we divide the polynomial? You divide x cube by x, the leading terms of both the dividend and divisor, it is x square. X minus 1 into x square will give you what? X cube minus x square, subtract 4x square, this will cancel out, bring down one term, again the leading term here and leading term here, divide them, you will get 4x. X minus 1 into 4x will be 4x square minus 4x, subtract, this will cancel out, it is 8x plus 5. Leading term here, divide again, 8x by x is 8. Multiply x minus 1 into 8 will give you 8x minus 8, subtract. This will cancel out, you will get finally remainder of 13. This is by polynomial division. You are getting a remainder of 13 after such a long process, right? Now, if you use remainder theorem here, notice the difference in the process. Here, can I say f of x is this? Divisor is x minus a is 1. Then by remainder theorem, can I say remainder will be equal to f of a is 1. Now, what is f of 1? F of x is this. What will be f of 1? 1 cube plus 3 into 1 square plus 4 into 1 plus 5. When you add it all, you directly get the answer as 13. Look at the time difference. Here one would take easily a minute. There I will get my answer in 10 seconds or maybe less. So, remainder theorem is that way very, very powerful method, right. So, this is what is remainder theorem, the statement. Now, one variation of this could be if f of x is divided by x plus a, instead of minus a you have plus a, then remainder will be f of minus a, okay. So, remainder theorem, this statement can be used in our problems involving calculations of remainders in the following manner. Observe, look at the following questions. Say the question is, find the remainder when 5 to the power 76 is divided by 26. Okay, 5 power 76 is divided by 26. So, how do we find the remainder? So the method would be, please note, consider the divisor. What is divisor equal to? 26. Our divisor should be of the form x plus a or x minus a, right? So can we write this as 25 plus 1, which is nothing but 5 square plus 1. And here I say, let us put 5 square as x. So when I do that, can I say my divisor will be x plus 1, correct? So divisor is in terms of x plus a, or rather x plus 1. What is my dividend? Dividend is 5 power 76. Now can I write 5 power 76 as 5 square whole power 38? Yes. See, the reason why we are doing this is, we already placed 5 square as x. My divisor is in terms of x. I want my dividend also in terms of same x. That is the objective. So thus we can write this as x to the power 38. Correct? 5 square is x, x power 38. Now you notice, you have a dividend which is of the form f of x. You have the divisor which is of the form x plus a or x minus a. Now using this, can I say my remainder directly from remainder theorem will be f of minus 1, yes or no? If x plus a is there, remainder is f of minus a. So how much will be f of minus 1? It is going to be minus 1 to the power 38. Replace x by minus 1. Minus 1 to the power even power will give us plus 1. So this is how we could find out the remainder in case we wish to use remainder theorem. So this is one small example. Of course, you can also use pattern method for this. You could have used it, or maybe observation method for this. Both would have worked. The third method is this remainder theorem method. See, the reason why we are introducing this is, if not in numbers, at least in your polynomials, algebra part, you will come across such questions perhaps. So over there, this would be the easier way to find the remainder rather than going for this polynomial division. So that's one use of remainder theorem. Besides this, the previous use, there is one more major use. There are some problems in numbers which can only be solved by using remainder theorem. There is no other way at all. We will take up one such example in our subsequent video. Today I just plan on introducing the concept. We will take up the example in the next video. But before we go for that, there are just couple of points here. So the 2 points that I wish to share and I want you all to note down is, while applying remainder theorem, we need to keep two things in mind. One point is the divisor and remainder. Both should be powers of the same base. For example, if divisor is 5 power something, my dividend should also be 5 power something. If my divisor had been 3 power something, my dividend will also be 3 power something. I cannot have a case wherein the dividend is 3 power 76 and I am writing my divisor as 5 square plus 1 type. So bases should remain the same for both dividend and divisor. So dividend and divisor must have the same base. If they don't have same base, don't use this. We can't use remainder theorem. We will have to use pattern method. Second point is, in majority of your problems in remainder theorem application on remainder calculation, majority of your problem, I would say 99% of your problems, the value of a that you are taking, should be plus or minus 1 only. Think why. Imagine this, had this been 2 for time being, just imagine, had this been 2, then my divisor will be x plus 2. So f of x is divided by x plus 2. So my remainder will be f of minus 2, correct? So what is f of minus 2? Minus 2 power 38, which itself is a task. Now what is 2 power 38 value? We don't know, it will be in millions and millions. So hence, this remainder theorem concept will make sense only if you have something like 1 power something or minus 1 power something. If you have 2 or 3 or minus 3 here, things will not work out. So this is second point that we need to keep in mind, that majority of our questions, value of a should be plus or minus 1. If it is not, don't use remainder theorem. So these are some basic points about the remainder theorem. I hope we have followed it. Now what we shall do is, we'll be ending the session here. So before we end it, just give these channels, alright, these websites a look. You will find some useful content there, I am sure. And in case you want to enroll for your CAT course, alright, or any course of your choice, alright, maybe a bank SSC course, you can visit our nearest center, get in touch with them, see what batches are they launching. You can just get that information from them. On that note, let me end the session here. Thank you and all the very best.